Now, let's look at the final example of part 3. In this example, we are told that AB and DC are chords of the circle. We are also told that E is a point on AB, such that BCDE is a parallelogram. Now, we are also told that D angle EB is 108 degrees. We are also told that D angle AE is 2x plus 40. D angle AE is equals to 2x plus 40. We are told to find the value of x with reasons. And for us to find the value of x with reasons, we need to know what is a parallelogram, because they said E is a point on AB such that BCDE is a parallelogram. Now, a parallelogram, we know, it's a four-sided figure where opposite sides are equal. That's the first property of a parallelogram. Opposite sides are equal. Opposite angles are equal. Opposite angles. This angle is equals to that angle in a parallelogram. This angle is equals to that angle in a parallelogram. Therefore, in a parallelogram, opposite sides are equal. Sorry, opposite sides, yes, are equal. Opposite sides are equal. And opposite angles are also equal. Opposite angles are also equal. Therefore, this side is equals to that side. This side is equals to this side. This angle is equals to that angle. This angle is equals to that angle. We also know that in a parallelogram, because we want all properties of a parallelogram, we also know that we've got parallel sides in a parallelogram. Opposite sides are parallel. Opposite sides are parallel in a parallelogram. Therefore, this side is parallel to that side. This side is also parallel to that side. But the property that we need here is the one of opposite angles of a parallelogram. But before I can find the value of x by elimination, I need to eliminate all the theorems which are not in this problem. Before I can find the value of x, I need to eliminate all the theorems which are not in the problem. Now, let's eliminate. Are there chords? Yes, there are. Are there cyclic chords? I'm going to pack the question of cyclic chord. Are there tangents? There are no tangents. Therefore, all the theorems of tangents are out in this problem. Now, we want to eliminate the theorems on chords, then we want to look at exactly what is happening with cyclic chords here. Now, we want to eliminate theorems on chords. Is there a line from the center to the midpoint of the chord? No. Is there angles at the center 2 times angle at the circumference? No. Is there diameter? No diameter. Is there angles at the same segment? No angles at the same segment. Therefore, theorem number 1, 2, 3, 4 are out for chords in this problem. Now, cyclic chords. In this problem, we are not given that ADCB is a cyclic chord. We are not given, but somehow we are told that ABCD is a cyclic chord. How is that? Since we are told that AB and DC are chords. If they are chords, it means that the endpoints of these chords are on the circumference. Since the endpoints, because we know a chord, it's a line that divides the circle into two segments. This chord divides this circle into this segment and this segment. This chord divides this circle into this segment and this segment there. Therefore, it means that the endpoints of the chords are on the circumference. Because if you are a chord, it means that your endpoints are at the circumference. Therefore, the endpoints are at the circumference. Endpoints for this chord DC is at the circumference. Therefore, any four-sided figure will be a cyclic quadrilateral. It means that ADCB are cyclic, or they are cocyclic. ADCB are concyclic, are points on a common circle. So they ADCB are chords on are points on a circle. So it means that they are concyclic, since we are told that AB and DC are chords. So it means that their endpoints are at the circumference. Therefore, we do have a cyclic quad, but we are not told immediately, or we are not told that ADCB is a cyclic quad. For us to say there is a cyclic quad, we need to be told. But here they told us, but in not by telling us per se that we do have a cyclic quad. But we do have a cyclic quad now, since we are told that AB and DC are chords. Now, we are told to find the value of x. Therefore, we know that theorem number 5 is there. Theorem number 6 is not there because there's no exterior. There's no exterior. There's no exterior. There's no exterior. The exterior angle here is only for the parallelogram, not for the cyclic quad. So there's no exterior angle of cyclic quad ADCB. Therefore, theorem number 6 is out. We only have theorem number 5, where we have opposite angles, which are supplementary. We know theorem number 5, opposite angles are supplementary. Therefore, we can now find the value of x. So for us to find the value of x, we are first going to say that D angle E B is equals to B angle C D. D angle EB, which is this angle, is equals to B angle CD, which is equals to this angle. Reason? D or B, C, D, E is a parallelogram. Because we've just said it, that opposite angles of a parallelogram are equal. Therefore, since BCDE is a parallelogram, it means that this angle is equals to that angle. Therefore, we now know that B angle CD is equals to 108 degrees. Now, therefore, since we know this angle here, that is 108, and we know that ADCB is a cyclic quad, therefore D angle A, B or E plus D angle C, B or B angle DC is equals to 180 degrees. This means that this angle, which is D angle AB, which is this angle, plus D angle CB, this angle, is equals to 180 degrees opposite. angles of cyclic quadrilateral. Opposite angles of cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. Now we know D angle AB 2x plus 40 plus D angle CB 108 degrees equals 180 degrees. Now we can solve for x. For us to solve for x, obviously, we're going to have 2x plus 148 degrees equals 280 degrees. We're taking this one there, which is 2x is equals to 180 minus 148, which is equals to 32 degrees. Now we divide by 2, therefore x is equals to 16 degrees. So we have tried to solve a lot of problems, but there's a lot of problems obviously which we still need to do, but we can't do all the problems. But this is just about how we need to eliminate the theorems which are not in a problem. Use also part 1 together with the theorems which are in a specific problems. I think it is much more easier now to solve geometric riders, since we have tried to make sure that we give you a way of solving these problems by first eliminating the theorems which are not in a problem and use them together with what we have learned in part 1. Now, if you've got any other problems in grade 11 geometry that you want us to do, you can drop them down in the comments and we will do them. Thank you.